All right, so this problem asks us to figure out the net present value for project A and project B, and so let's go ahead and do that. This one will probably take a minute, so let me kind of scroll down here. Hopefully you have your, well, I can't quite get to where I want to be. All right, so hopefully you have your information in front of you and you can see where these things are going. So for project A, I'm going to kind of set this up the way you would have been doing your homework. So we have the activities, the years, the amounts, the present value factors, and finally the present value of the cash flows. So for project A, our first activity is the cost of equipment. When does that happen? That happens now. The amount is $90,000, and I always use the positives and negatives, right? Is it a cash outflow? Is it a cash inflow? So I don't get confused by that. The present value factor, for any inflow or outflow that happens today, the factor is always 1. The present value of $1 today is $1. So that gives me, right, I multiply those, and that gives me the present value of minus 90,000. The next thing we have for project A is the annual cash inflows. So, annual cash, pretend that says inflows. When does this happen? Well, it happens through years 1 through 6. The inflows or the savings are $29,000 a year. And the factor, and in this case, because this is not a one-time amount, this is what we call an annuity. So when we go to the present value tables, we're not going to use present value of $1. We're going to use present value of an annuity. And what we're looking for here, the problem tells us the rate of return is 14%, so we're looking for 14%, and this project's for 6 years. So 6 at 14% is 3.889. So I multiply that times 3.889, and I get an inflow of 112,781. The final one for project A is the salvage value. When does that happen? It happens in year 6. The amount is an inflow of $10,000. We sell the equipment, we get $10,000. We need to figure out what that is in present value. And in this case, this is a one-time amount. So we're not getting $10,000 year after year after year. We're getting $10,000 one time and in year 6. So we go to 14%, so present value of $1 or a single sum, 14%, 6 years is 0.456. So I multiply 10,000 times 0.456. This is an inflow, $4,560. So I add those up, the outflows and the inflows, and I get net present value of positive 27,341. Now let's look at, I'm going to scroll down just a tad, and let's look at project B. Same idea. I've got the activities, I've got the years, the amounts, the present value factor, and then the present value of cash flows. Pretend that says cash flows. Now we had more items related to project B. So again, we're just going to check them off though. We have the initial cost. When does that happen? Now. What is the amount? 40,000, and it's an outflow. If it happens today, the present value factor is 1. So the present value of that is 40,000. We also, this ties up some working capital. Working capital is our current assets minus our current liabilities. So I'll just abbreviate that WC. So the working capital, when does that get tied up? Now. What's the amount? Minus 45,000. That's tying up our funds. So it's an outflow. Since it happens today, the present value factor is 1. So the present value of the working capital today is minus 45,000. Then we have our annual cash inflows. When does this happen? Well, they happen years 1 through 6. We estimate that this savings or inflows are going to be 25,000. And we need to multiply it by a factor. Now again, this is an annuity. This is happening. This is a payment. This is happening over and over again. So we're going to look at the present value of an annuity. Again, 14%, 6 years. It's the same factor we had calculated earlier, 3.889. So we multiply that out, we get positive 97,225. Now we have a new one here we didn't have to consider before, the cost of repairs. So it says that with this project B, there's going to be a repair cost. I should have wrote repair cost instead of cost repair, but anyway, and that happens in year 3, and that's going to cost $5,000. So that's an outflow, right? We're going to have to pay that. Now we need to figure out, again, this is a present value of a single dollar. It happens one time at the end of year 3. So 14% for 3 periods is 0.675. So I multiply that by 0.675, and I get minus 3,375. And finally, when this project is done, we get a return of working capital. And when does that happen? That happens in year 6. We get our 45,000 back, but it's not worth what it is today, right? Because it's 6 years from now. So we go back to the present value of a dollar, 14%, 6 periods, we get 0.456. And that gives us positive 20,512. We add all of those up, and that gives us net present value of 29,370. So both of these have positive net present value. So number 2 says, based on your calculation, should we choose either of these? And the answer is yes. They both have positive net present value. If net present value is positive, that means the actual return is greater than the required return. So both of these projects are earning a return greater than 14%, and so we could accept either one of them. So this video is a little bit longer, so decide to figure out which ones we're going to accept. Watch the next video on the Profitability Index.